Hello everyone, welcome back to Math 143. Finite Mathematics. In our previous lecture, we learned about simple interest and compound interest. So, within the lecture, we saw that compound interest allows your money to grow faster because interest is earned not only on the original principal but also on previously earned interest. Today, we will continue the same section by discussing three very important financial concepts: continuous compounding, effective interest rate, and present value. So, these concepts are widely used in banking, investment, mortgages, retirement planning, and many financial decisions you will make throughout your life. By the end of today's lecture, you should be able to calculate accumulated amounts using continuous compounding, compare different investment accounts using the effective interest rate, calculate the present value needed to achieve a future financial goal, decide which investment option is better using mathematical calculations. Okay, before we move forward, let's quickly review the compound interest formula from our last lecture. So, the compound interest we write in A equals P times 1 plus R over M to the power MT. Here P is the principal amount, R is the annual interest rate, M number of compounding periods per year, T time in years, and A accumulated amount. Okay, if interest is compounded monthly, what is the value of M? Monthly, M equals 12. What if it is compounded quarterly? M equals 4. Okay, then now let's think about something interesting. Suppose instead of compounding monthly, the bank compounds daily. Would you earn more money? Yes. So, what if it compounds every hour? Even more interest, right? So, what if the bank compounds every second? Even more interest, right? So, this raises an interesting question. What happens if the bank compounds interest continuously? So, this leads us to our first topic, continuous compounding. Continuous compounding. Okay, when the number of compounding periods becomes extremely large, when the number of compounding periods becomes extremely large, we say that interest is compounded continuously. So instead of using the compound interest formula, we use the different formula. So the compounded continuously, we use A equals P times e to the power RT. Here P is same principal amount, R, annual interest rate. T, time in years. Time in years. Here E, Euler number. E is the Euler number. In your calculator, I hope you saw the E, function E. The Euler number is a mathematical constant, just like 5. So the Euler number, which is 2.71828. So let's define that E is the Euler number, or Euler's number. E, Euler's number E is a mathematical constant. Your calculator has an e to the power x button. So you can use that button to evaluate this expression. So let's see the example. Example, Tina invests $3,000 at 7% interest compounded continuously. For 5 years. For 5 years. Find the accumulated amount. Okay, so let's identify the information given in the problem. So the principal amount, P, $3,000, because Tina invests $3,000 original amount. Interest rate R, 7%, 0.07. Time T in years, 5. Also, the problem says compounded continuously. Therefore, we should use the formula A equals P times e to the power RT. Then let's substitute the values into the formula. A equals 3,000 e to the power RT. A equals 3,000 times e to the power 0.35. Using the calculator, you can get e to the power 35, approximately 1.4191. Therefore, A equals 3,000 times 1.4191. A equals 4,257.30. So let's round out up to the nearest dollar value. A, 4,258 or 58. So then how much interest was earned? I equals A minus P 4258 minus 3000 1257. In total 1257 interest. Okay, let's go through the next example. Example 2. Tim invests $5,000 at 9% compounded continuously for 15 years. Okay, pause the video, try it by yourself. First, identify the information and substitute it into the formula. Check your answer. Okay. So let's discuss then. So, which grows faster? Monthly compounding, daily compounding, continuous compounding. Which one? Monthly, daily, or continuous compounding. So the continuous compounding always produces the largest accumulated amount for the same nominal interest rate and investment period. So the continuous compounding would be the fastest growth option. Okay, then I hope we can move forward. You can try all the exercises and examples on your notes. Please make sure to do it by yourself. Okay, then next. Let's move forward. The effective rate of interest. Or effective interest rate. So now let's suppose two banks advertise different interest rates. Let's suppose two banks advertise different interest rates. Bank A offers 7.40% compounded semi-annually. Bank B offers 7.25% compounded daily. Okay, which account is actually better? Which account is actually better? So we can compare only the nominal interest rate 7.40, 7.25. So the 7.40 is larger than the 7.25. Therefore, just say the bank A would be the better one. No. Instead we use just the nominal interest rate. We calculate the effective annual interest rate. The effective annual interest rate can help us to find out the better investment plan. Okay. Effective annual interest rate, REFF, 1 plus R over M to the power M minus 1. So the all terms are RM. R means the annual interest rate, M number of compounding period per year. The effective interest rate tells us the actual percentage earned after 1 year, taking compounding into account. Let's see the example. Compare Bank A 7.40 compounded semi-annually, that means M equals 2. Bank B 7.25% compounded daily, M equals 365. Let's calculate Bank A first. For Bank A, R equals 0.074, M equals 2. Then substitute REFF 1 plus 0.074 over 2 to the power 2 minus 1. The value should be, using your calculator, 1.037 to the power 2 minus 1, 0.075369. The effective rate 7.5369%. Then now for Bank B, R equals 0.0725, M equals 365. REFF 1 plus 0.0725 over 365 to the power 365 minus 1. Use your calculator. The approximate value 7.519%. So then let's compare the two values. Okay, for this one, compare to REFF. So we saw that the Bank A has slightly higher nominal rate. Also, within the calculations, we can identify that we can confirm the effective rate. It is also slightly better for Bank A than Bank B. Therefore, Bank A is better investment. Although Bank A has a slightly higher nominal rate, the effective rate. The effective rate confirms it is also slightly better. Therefore, Bank A is the better investment. So I will give you the extra example. So let's say exercise. Which is better? 6% compounded monthly or 5.9% compounded daily. Okay, pause the video and have all the information, compute both effective rates and compare the two effective rates. Okay, then let's begin the present value. Suppose you have a financial goal. Maybe you want $40,000 5 years from today. How much money should you invest today? This is called the present value. The present value is today's value of the future amount of money. The present value is today's value of a future amount of money. So let's say maybe you want $40,000 5 years from today. How much money should you invest today? This is called the present value. Okay. The present value formula this formula simply rearrange the compound interest formula to solve for the principal amount. The compound interest formula A equals P times 1 plus R over M to the power MT. Then principal amount A over 1 plus R over M to the power MT. Simply rearrange the compound interest formula to solve for the principal amount. Example, Michael wants $40,000 after 5 years so the bank pays 3.5% compounded quarterly. How much should he invest today? So identify the information. Future amount A, $40,000. Interest rate R 0.035. Compounded quarterly M equals 4 and time T equals 5 years. Then substitute it into the equation, the formula 40,000 over 1 plus R over M to the power MT. P equals approximately 33,593. Therefore, Michael should invest approximately $33,593 today. Right? So, now suppose interest is compounded continuously. So then write the present value formula using the compounded continuously formula. So A equals P times e to the power RT. P equals A times e to the power negative RT. Then substitute the same values. A 40,000 e to the power negative 5. P equals 33,577. So, which investment requires less money today? Exactly, the continuous compounding. So, why? Since money grows slightly faster, therefore, less money is needed initially. So, here are several practice problems. Please make sure to practice the problems. Exercise 1. The final accumulated amount 8,000. Interest rate are 5%. Continuous compounding. $10 years. Practice problem 2. Compare 6% compounded monthly %, compounded quarterly. So hint, use the effective interest rate. Practice problem 3. How much should you invest today to have? How much should you invest today to have $20,000 in 8 years at 4% compounded monthly. Practice problem 4. How much should you invest today to have $20,000 in 8 years at 4% continuous compounding? So, the biggest mistakes students make are forgetting the convert percentage into decimals, using the compound interest formula when the problem says compounded continuously, forgetting to divide the annual interest rate by the number of compounding periods, using the wrong present value formula. Also, forgetting to identify whether the questions ask for the future amount or the amount to invest today. So please keep this in your mind. Please don't do the common mistakes. So let's summarize today's lesson. Today we learned 3 important concepts used in finance. First, we studied continuous compounding, where interest is compounded continuously using the exponential formula. Second, we learned how to compare investment accounts using the effective annual interest rate, which allows us to fairly compare accounts with different compounding frequencies. Finally, we introduce present value, which tells us how much money we need to invest today to reach a desired future amount. These concepts are widely used in savings account, retirement planning, mortgages, investments, and many financial decisions. So in our next lecture, we will continue exploring financial mathematics with annuities and related applications. Thanks for watching, and I will see you in the next lecture.